I'll do this. Hello. I'll do a small C tutorial. So go to our web browser. You won't be downloading compiler today. You just use an online compiler. So go to Programming Pro and you see something like this. You can put in dark mode if you want. Let me increase the size. Okay, so first thing you do is to declare your int main function. So this is the target your compiler will look for to run. And if you want to print something out to terminal or this output here, you import stdio.h. So you use this include preprocessor or keyword stdio.h, which is a header file. So you now have access to built-in functions like printf, ho, 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 and you can now run this. You print this out. Okay. So after that, you can there's also things like variable declaration and assignment. So to declare a variable, you do it like this. Equals to 19. And if you want to print this out into output here, you use an identifier which starts with a percent sign and this specific identifier for int is d. Then now add the variable. Oh, let me clear this. So when I run this, you can see the number will be printed out at the end of this sentence here. That was 19. You can also add the literal 19 or let's say 18 here. Run this, you now print 18. So this right here is called the literal. And what they are, let me check. Literal in C. Basically, they're just constant values like 0, 1, 2. There's for floats, character, there's string literal. So basically, they're just constants. They're the type of constants. You can also make a constant variable with this const keyword, the data type, and the variable name. Then you can now limit 88. And you can now let me put this inside here, variable name, and you have it present at 8080. So what this const keyword does, is that I can't reassign it a new variable, no matter what. This variable cannot change. So let's say if I want to assign to 80, it should give an error because it's a const. Assignment of read-only variable, I don't even know. Okay, so there are other data types apart from this int, which means integer. There's the float, there's the double, and there's char. So let me start with char. Char is just a single unit of a string, which is like this. You can't do like this. No, that's not a character. That's a string now, and that can't work here. You give an error because that's not a character. Character is a single unit of a string. I see no errors. There's also floats and doubles are just decimal numbers. 9.9 like this. And I think that's all the major data types now. Okay, so what else? Oh yeah, the scanf. The scanf function. It allows you to assign a value to a variable depending on the user inputs. For example, let's say I have this integer here, another hoe, and let's say I write a message for this send funds. I'll use this format identifier here. Then I add this and percent or this and sign and the variable name called ho. So what this will allow me to do is that it will allow me to assign a value to ho when the on my output here when I put in a value in this output here. So let me put this and the and let me print this out when I'm done. So I run this. Hold on. Mistake printf. Okay, so 19. Run. As you print not a huge number. Hold on, let me try this. Nine. Nine. Let me see sky. Hold on. I think I made a mistake here. Int this. Oh, no wonder. Oh, no wonder. Shit. That makes sense. So, that explains why. So I can just remove this. This before here. This for. Okay. That explains why. So let me just write that text. So, oh, okay. Okay, that works. So what this and percent, this symbol here does is it creates, it shows the memory address, exposes the memory address of this variable. So basically, this would be called a pointer. And a pointer is just basically a memory address, a variable that stores a memory address. So it basically allows you to manipulate this value here. After that, now let's do functions. So basically, this is a basic type of function. So this is the main function itself. This is what the compiler looks at for, but you can define your own function. For example, let's say you have int user defined yes. So you can define your own function right here. You can print f here. Mhm. Okay, and I can now call this function here user defined bs. So what this does, so when I run this, this will give me an error because this I'm calling this function when I've not been defined when the function has not been defined earlier. So this right here is called a function definition. So when I run this, it gives me an error. Yeah, because it cannot find the user defined bs. So I have to define the function before calling it. Okay. So then I see, and I found it. After that, oh yeah, let me go back in. You can define the in functions. You can add arguments to it. So arguments looks like this. You can define argument by specifying the type, then add, then calling out a name for the argument. And I'll now put this here. Yes, the math specifier, then the name of the argument. So now I would have to call. So now I have to add a value inside function. I have to pass in the value. So I'll say 90 here. So it's 90. But if I remove this value here, it should give an error. Alright. So it was expecting that I put in a value inside this function when I call it. So remember, if you define an argument here, you should also add a value that's of the same type. But what happens if I add a value of a different type? So usually what happens is that I have some unexpected or undefined errors. Probably print a different value. Oh, it's not. Hmm. So actually automatically rounded that down for me. Okay, so automatically rounded that down for me. Uh-huh. Let me also try this. Int in. So I'm try printing this. Printf. Format specify d. Format specify d. Then a. I think this is the one that should print random values. I try it again. Try it again. So basically just printing random values from here. So basically you should always immediately assign your variables to prevent it having random errors like this. So I have this print 8. I think that's all. So remember, notes, this one equals to signs for assignments. There are places where you can put multiple equals to sign. I'll show you. So I'll say, so I'll define A as 8. So let me put this 2 equals to sign and say 8. So this should print out 1. So yeah, so basically like binary. 0 means false, 1 means true. So 8 is, since I've already signed, so it compares these two values, compares this variable here and this integer literal. So it says that a is equals to 8. See that, so it shows that a is equals to 8. I can also do something like int b is equals to 8. And I can replace this 8, this literal here to b. And should I see 8? But if I say 7, it should give out 0. Right. So what else? So this two equals sign is a comparison operator. Compares two values. Or logical operator. Anyone. So let me define a new variable. I'll just define this as 9. That's 9. Just say f9. Unless, oh yeah, the increments and decrements operator we're doing today. Prints. So that guy in class today didn't even explain the increments and decrements operator well. Let me put F9. Let me also add this. So, so basically, these two plus plus signs increases this value by 1 and 2 decrement. So this, the 2 plus plus means increment, this means decrement. So this increases by 1. You can also add it to the front. So you do the same thing, and let's do the plus plus. It should do the same thing. So let me try this. C, C plus plus. Mhm. So basically, this is the same. So this C plus plus you see here is similar to just writing this, or so this initial sound, or C is equals to C plus one. But there's a difference between adding this at the front and adding it at the back. So when you're adding it at the back here, it has a specific behavior when you're like assigning it to another variable. For example, int Java is equals to say C plus plus. So let me say C plus two this and just use this T Java is equals to identifier C Java. So you can see that the value for C and the value for Java are two different things. So adding it at the back here will assign C the original value of C, which is this 9 here, to Java. Then after the operation is done, it increases it by 1. So this is an increment after an operation. But if I do it before, the values will be the same. So this is an increment before operation. So before it's assigned to Java, it increases it by 1 and assigns it to Java. So the same thing applies to the decrements too. So decrements 5 is then apply to see two different values. I want to try something. Can I do this? Oh, doesn't work. So I have to put something like a bracket here, bracket here. Oh, doesn't work. Doesn't work. Okay. After that, I think that should be all.